All right, so good afternoon or good morning, depending on where you're joining us from, everyone. My name is Jesse, and I am with Exploring by the Seat of Your Pants. For those joining us for the first time, we are all about bringing conservation, adventure, and science into classrooms around the world. And we are particularly excited because today is the day that our entire month of February is based on. All February long, we kick out all the men and welcome only incredible women from around the globe, from all sorts of places, every continent that you can imagine, every field that you can imagine, to highlight today, which is the International Day of Women in STEM, trending right now majorly on Twitter, which we're really excited about. And so thank you guys for being a part of this special day in this special month. So today's session is a little bit different than usual. You guys have signed up because we are highlighting an incredible campaign highlighting amazing women in science. And so I'm going to turn it over to Farah Quasar, and she is going to explain a little bit about why we're here today and introduce our speakers, and then we will dive in. So without further ado, thank you so much for joining us, Farah, and take it away.
All right, thank you, Jesse, and hi, everyone. I hope everyone's doing great. Thumbs up if you can hear me, and if everyone's feeling great today. I see lots of thumbs up, which is awesome. So today I wanted to share two incredible women in STEM role models with all of you, and I especially wanted to share them because they have very interesting journeys, and which I hope will be inspiring to all of you. Our first speaker is going to be Dr. Hind Al-Abadleh. She is a professor at Wilfrid Laurier University, and she studies chemistry. I'm not going to share too much about her journey because she's going to tell us more about that. And second, we have Dendra Hillier, who is a research technician at University of Western, where she's studying all about the brain. And fun fact, all of this today is possible because of Exploring by the Seat of Your Pants, so that's Jesse, and NSERC Student Ambassador Grant, who are giving us a lot of money to help send board games and calendars to classrooms across Canada. The See It Be It STEM initiative, who've put together a 2020 calendar of role models for science, and Ingenium, who've put together a Women in Science board game. But we can talk more about that later. For now, let's turn it all over to Hind, who's going to kick us off today.
Okay, hi everybody. Thumbs up if you can hear me well. Awesome.
We can hear you.
Okay, great. So it's great to meet all of you in this virtual class. Thanks to Jesse and to Farah for inviting me to be part of today's celebrations of the International Day of Women and Girls in STEM. And happy to be with you. My goal is to actually give you a brief, take you on a journey, if you will, that I have taken to become the academic scientist in chemistry at Wilfrid Laurier University, where I work and where I am based. So my campus is in Waterloo, Ontario, in Canada, and Waterloo is about 80 to 100 kilometers west of Toronto. So you're welcome to visit if you are in the area. So I'm going to share now my PowerPoint slides that will give you an idea of what I do and what motivates me to do the work I do. Okay. Okay, share screen, and then PowerPoint, and here we go. Yeah.
Perfect.
Okay.
Yeah.
Yes. Okay. As you're gonna see from these slides, my goal is to actually highlight how chemistry plays an important role in creating a healthy environment for all. So I'll start with my journey. I was born in Gaza, and then I went and did all my education from all the K-12 primary, elementary school, and middle school, and high school, and university in the United Arab Emirates, and then I went to the United States to study for my PhD and postdoctoral work. And then I moved to Canada to start my academic career as a scientist. So my inspiration for environmental issues and science in general started in high school, where I actually have completed a 50-page research paper on the impacts of chemicals on the environment and how acid rain forms, what is the chemistry behind the ozone hole, and also global climate change. And so during high school, I ended up actually corresponding with an institution for environmental activism in the Netherlands with the name of Friends of the Earth International. And they were really nice. They have sent me nice brochures and more information, and they encouraged me to stay active in this area. So when I was in university, I took university classes that actually highlighted a different dimension of chemistry, is that in order for us to have a sustainable, livable world, chemistry is important for research in energy, for research in green chemistry and processing, for research in environmental molecular science, and also for educating ourselves about the fact that as scientists play an important role in creating the environment and the future that we hope to live in harmony with the natural system. So at my job here, I do research in environmental molecular science, and I also teach courses, and I do outreach activities to increase awareness about environmental issues and the solutions about them. So my research focuses on the chemistry of atmospheric particulates, the chemistry of air pollution and climate change. I also have research projects on arsenic and phosphorus and organic matter in soil. And I also explore the chemistry of new materials for cleaning polluted air and water. And coincidentally, yesterday, the Chemical and Engineering News of the American Chemical Society have published a special issue with the title, How Chemistry Will Help Us Thrive in a Changing Climate. And in that special issue, they have listed, as you can see in this slide, a number of areas where chemistry plays a role in protecting the planet and saving the coral reefs, building climate resiliency, and also ensuring that we have a healthy planet and that we can live in for the future. So I encourage you to actually explore this edition in your classes. There is not, we stand on the shoulder of giants, and I'd like to take a minute to actually honor my mentors who were instrumental during my journey till I got to where I am right now. They start with my high school female science and English teachers who have inspired me and encouraged me and pushed me and challenged me to grow and to pursue harder problems with time. And of course, my undergrad mentor at the United Arab Emirates University, who was instrumental in facilitating my education in his classes and also beyond when I moved to the United States. And my mentors at the University of Iowa, at Northwestern University, who also supported my PhD and postdoctoral work till I become a publishing scientist with a name at the international stage. So where I am at Laurier, I teach courses in physical chemistry, environmental chemistry, and here I'm showing you a screenshot with a class that was happy after leaving final exams, and also with one of my research students, Glennis, who invited me to her graduation party. Was very happy to see her. She's actually from my financial mathematics, and she wanted to take physical chemistry classes to see how math is applied to chemistry problems. So it was really fun to have her in the class. These are a few photos of the research that I do in my lab and also at national research facilities like the synchrotron in Saskatoon, Canada. My research is funded mostly by NSERC, CFI, the Government of Ontario, the American Chemical Society. And also I have collaborations with companies like Imperial Oil, Petro-Canada, Hemera, and I do computational chemistry work through the facilities that Compute Canada offers. So I'm very grateful for their support of my research and my continuing partnership. Here are a few photos of the students who actually went through my lab and ended up finishing undergraduate research projects or graduate theses. It was fun and a privilege to have worked with them, and they have left the university to great careers after Laurier. And also for my collaborators in Canada and in the United States who have been wonderful in actually working on joint projects on the themes that I have talked with you about. And this is what I call my wall of fame, because see, scientists are in the business of producing knowledge. And the way we produce knowledge is through original, innovative research that we publish in scientific papers. And I am proud of every single paper I have published at Laurier with my students. And I feature all of these papers on a nice, big, large poster across the hallway of my lab, and that I call the wall of fame. So basically to take ownership of the work that we've done and for everybody to see what we were up to. And then we also go to conferences. I take my students and they present the work that they have done in posters or oral presentations. So these are just a few screenshots of the photos I've taken with my students at conferences. Some of these are small or short-term workshops where we get intense knowledge or crash courses on a very specialized topic, and you get to meet other scientists from around the globe as well. And I recently visited the Institute for Chemical Processes and Environmental Technology in Ottawa, Ontario, Canada. And there I got to actually meet young and upcoming scientists who are interested in energy research, who are interested in using plastics to generate fuel and to actually take out food waste and generate fuel out of it. So it was really a fun visit to see what they're doing. At Laurier, I engage in outreach activities to increase awareness of chemistry and environmental issues. And here are a few of the shots that I have taken during the launch of the Women in Science Center. So we've done chemistry demonstrations, as you can see, and they were a hit during the during the celebration for the opening of the center. Last fall, I was invited by the Society for Undergrad Research and Outreach to provide first and second year university students with tips for success. And I also was involved in the launch of 2 books, very instrumental in understanding the politics, the psychology, and the economics of climate change through work with the Sustainability Office of Laurier, through work with Students for Sustainability. And that was fun to be involved with as well. I also serve my chemistry community outside the university. I'm involved with the Canadian Society for Chemistry as the chair of the Environment Division. And also I work with a specialized work group that advises the board on equity and diversity issues within the chemistry community. And I also get invited to, women in science groups to talk about challenges and pathways and how to succeed as a female scientist. And I also work with Nano Ontario, which is an incorporation that is interested in facilitating and making sure that we have the ultimate use for nanomaterials, but also sustainably and in a healthy way. And to the wider community beyond the science community, I'm very passionate about celebrating Earth Hour and also working with faith groups on how they can green their sacred places. I also have been invited to radio shows to talk about this issue and how to translate science to the masses, if you will. Same with a local radio station. And also our organizations of multi-faith group that have invited me also to talk about science and faith that you normally do not think they actually have a lot in common, but they actually do. And also I got invited to a number of high school and primary schools, private and public in Ontario, to give lectures about what every citizen should know about the Earth's atmosphere. I think that's very important that we have citizenship around the world that understand the chemistry, that understand the science, so that they make political decision-making that are evidence-based, and that is very important. So I love to engage with the wider community on that. So I hope that through this journey that I have shown you examples of how my research and teaching and outreach address 14 out of the 17 Sustainable Development Goals that you see listed here when it comes to good health and well-being, when it comes to climate action, life below water, life on land. This poster motivates me every day to come to work, and I hope it will do the same for you. We have a lot of work ahead of us to continue to preserve what we have from natural resources and to continue to build a more sustainable future. So thank you for the opportunity to talk to you, and I look forward to your questions.
Thank you so much. Wow, you do so much every day.
Find time to sleep in there occasionally.
So now I'm going to pass it over to our second speaker, who is Dendra. Dendra, do you want to give us a thumbs up if you're on?
Yes.
Do you want to unmute yourself?
There we go.
Yes,
Hear
there
me
you go.
okay?
Yeah, we're perfect.
Awesome. Well, that was amazing. That was such great work. To hear about what you're doing is amazing stuff, and it's really important for sure. So I'm going to try to get this up and running. I have a couple of slides. I'm so thankful to be able to talk to you guys today. And basically what I wanted to start out with is you guys probably think of scientists maybe as, you know, some mad scientist with crazy hair and he's pouring all these potions into tubes. And I want you to know that scientists look like anybody, like you and me, and you can be an interesting, multifaceted person in science, no matter what. So for me, I am someone who loves being outside. I love fishing. I love hiking and traveling. So a scientist can be truly anyone, as long as you're curious enough about the world around you. But I think what started my journey was back in high school, very similar to the last journey we heard about. But I, in high school, kind of explored all kinds of different things. And I think it's really important that you guys do that too. So I was looking into, I was playing flute for concert band and jazz band. I was in a musical, as you can see in this photo. So that's me in full costume for Footloose, the musical. And so I was exploring all these sides of myself, and I think it's really important to do that so that you find something that you guys really, really like to do. I was also in leadership camp, committee, and student
We can't
council.
see your screen.
Oh no!
Do you
Shoot.
want to hit the green share button?
Yeah, what happened?
Oh no,
Was it sharing?
no, we did a test earlier and it worked. It took a while to come in. That's okay. You were
Okay.
coming along there.
There.
I
Desktop.
would love to see those pictures.
Right again. Yeah, they're really funny actually.
Perfect.
I think I got. Oh, you guys have it? Okay, perfect.
Just fill your screen with it. I'll let you know when it's all good, and then we'll go from there.
Okay, let's try that.
There we go. Perfect. Yay.
Yay! So here are all my silly pictures. But basically, yeah, I'm in. This is the musical photo. This is my leadership camp committee. So yeah, I think it's super important to explore everything. But I had a high school teacher that really pushed me, and she was really amazing at putting lessons together and putting experiments together that were super interesting, and it was in biology. So I got really interested in biology, so I took that in school afterwards. So I went to the University of Guelph, so that is in Guelph, Ontario, Canada, and I did a Bachelor of Science and a Master of Science. So my Bachelor of Science, I was looking at genetics. So that's what makes us all unique. It makes us all different. And I was studying how those genes work and how they make us unique. And then when I did my master's, I started looking at the brain. So I don't know if you guys have ever thought about this, but have you ever thought about how you come to a decision? So why did you decide to eat what you had for breakfast? Why did you decide to go to bed at a certain time, or what outfit did you pick out today? So there's a region of your brain that's really responsible for this, and it's called the cortex. So it's this big yellow area, and that's what I studied in my master's. I wanted to understand how that area of the brain, which is the outside of your brain, how that grows when you go from a little tiny egg to a baby. And so I really started loving research, and that's what, when I graduated, I was able to do. So I got hired at the University of Toronto, and I worked for a researcher, similarly looking at that same area on the outside of your brain, but now in an adult, and how, if you've ever heard of something called a stroke, it's what we call an injury. So you end up losing blood flow to one area of your brain. And we were studying how after a stroke, the cortex can be injured, but also heal itself. Because the brain is actually really amazing at healing itself, and it has some really cool ways of doing that. After that, I moved to the University of Western Ontario. I moved to London, Ontario, and that is where I'm currently at. This is the lab that I work in. So my current research involves looking at the brain again, but now in the baby, and how that develops when you're very, very young and in your mom's belly. And I get to essentially do research. I get to present research like I'm doing right now. And I also get to be a teacher. I get to train students in my lab, help them with their experiments and their design. And I really get to wear a ton of different hats throughout the day. So it's really fun. And I think if you do go into science, you get to wear a ton of different hats. It's always changing and it's super fun. But most of all, I think it's important to do something you love, first and foremost. And I did hear that we were maybe going to touch on this later. I was in the See It, Be It, STEM It calendar. I feel very fortunate to be included in this awesome group of ladies. And if you guys are getting this calendar, read all the bios of these women. They are business women. They are super talented in their own right. And so keep an eye out for that. And that's really all I have. So.
Fantastic. Well, thank you so much to both. No, this is really great. Thank you so much to both our speakers for joining in today. This is really amazing stuff. And so if you want to come out of screen share, then what we'll do is we'll turn it over to our teachers to ask some questions. We've got a bunch of groups watching on YouTube as well. So if the YouTube classes want to type in questions, please do. Don't be shy, and I'll pass along as many as I can. But for our classes, if you guys want to talk about the specific jobs that both our scientists joining us today do, about how they got into STEM, about opportunities for women in science, any question is yours to ask. So we're going to start with Miss Carton's group and then dive right in. Come on up, guys. Let's see. Oh, so Michelle, if you could demute your own mic. You're just having a little trouble for me. There we go. Perfect.
Question. I think we're still digesting what we heard.
No worries.
So I'll ask a question for us, I guess. I'm wondering, so since we are still younger, we don't necessarily know as much about chemistry. Can you guys tell us something that's really cool, or something that's like, ooh, people who do science get to do this, or like just something that might encourage us to look more into it?
Yeah, fantastic. So for both our speakers, if you guys both want to take that, anything that's really exciting to inspire young kids.
I think definitely you should take it being chemistry. I think you have probably some really cool stuff.
Well, I remember, I think the coolest chemistry I have done is using kitchen ingredients. I remember an experiment that I have done in high school that was called the dancing spaghetti. And it's basically, we got the spaghetti and we just cut it into shorter pieces of pasta. And then we added a little bit of vinegar, a little bit of bicarbonate, and we created a reaction that releases CO2. And when you have pasta in that mix in a long graduated cylinder, you will see the pasta moves around because there's bubbling of CO2. And we were just wowed by the fact that pasta can actually dance. And it turns out that
pasta or raw pasta.
What's that?
Cooked pasta or raw pasta?
Raw dry pasta. Yeah.
Perfect. We'll get the class to do that later. I'll try and find that on YouTube somewhere and we can see if we can share it with the classes. But yeah, chemistry is fantastic. I mean, you guys are all in middle school right now. When you get to high school, there's so many more opportunities and you'll get actual chemistry professors teaching you and teachers showcasing some really, really cool experiments. Fantastic, guys. Farah, actually, before we keep going with questions, did you want to explain a little bit about the See It, Be It, STEM It calendar?
For sure. So the See It, Be It, STEM It calendar, which I'm going to link in 10 seconds, it's basically a calendar with all your 12 months. And in each month, what happens is that you get to see a model who kind of shares their science journey with them. Dendra, I don't remember which month you are. I think you're October? September. So if I will link in the calendar right here. And you can actually order a calendar for yourself. If you're here in Canada, I'm happy to send it to you. But basically, you can see all these different incredible women in different parts of STEM. Some are engineers, some are biologists, some are chemists. Some aren't even in science anymore, but they're working in the business world, using that science that they've learned early on to apply it to other important problems. But that's not the only Women in Science initiative. There's also Ingenium, which is a museum here in Canada. And they've actually created a traveling exhibit where they've created posters and board games and little video games where you can play along and see what women in science have achieved. So I can also link that in. But basically what I'm trying to say is that there are so many women in science role models out there. And today we're just hoping to connect you with some of them. Yeah.
Fantastic. No, that's amazing. And I'd also encourage all our classes to go on Twitter. So again, in Canada and the US right now, I think it's trending #1 is International Day of Women in Science. So there's so many stories out there, whether that's the UN, various universities, National Geographic, etc. So great opportunity to learn a lot. Let me go to Miss Presley's class. If you guys want to come up with a question, go for it.
Courtney goes first.
Okay, come on up.
Come on up.
All right.
So I kind of have 2 questions.
Yeah.
So my first question is, do you have to observe atoms?
Ooh. Do you get to observe?
Lovely. I love that question because actually I highlight that in my classes as well. Like, how do chemists see atoms? How do we know the electron exists? How do we know that, you know, when 2 chemicals react together, they produce different things? You know, chemists are different than biologists. Biologists usually have a microscope, and then they prepare their sample on a slide, and they put it under the microscope, and they just look, and then voila, you know, they get to see a lot. But chemists, our microscope is actually electromagnetic radiation. We know the electron exists because the quantum theory that revolutionized science and created a new type of mathematics. So the very concept of the electron is actually a solution to an equation, a mathematical equation. And there were experiments that were done to prove the math behind quantum theory. So it's very important that you actually love math, learn math, and thrive at it. How do we see atoms? Well, we know we currently can use techniques like called the scanning tunneling microscope. It is based on the fact that at the atomic level, we can amplify the quantum behavior of atoms and electrons, and then we can use a phenomenon called tunneling that can create an electrical current. And that microscope is based on that. So we can actually scan through a surface and get a composition of that surface and know where the atoms are. But in general, chemists see molecules through the employment of electromagnetic radiation. There is a science called spectroscopy, and spectroscopy is the interaction of electromagnetic radiation with matter. Atoms are matter. Electromagnetic radiation that includes infrared, X-rays, all of that can help us see atoms and molecules.
Fantastic. And for our classes that are younger, how expensive are these fancy microscopes that enable us to see these materials?
Well, they're very expensive. You know, I mean, we're talking $500,000 and above. But you know, in this day and age, if you actually just Google or you go YouTube and just say scanning tunneling microscope, you will see very nice videos that explain the principles of STM and show you some images. But
$500,000. So there you go. So these once you guys have been in school for 20 years, you get to play with tools that are $500,000, and that's something you really look forward to as you get older. Amazing. Thank you so much. Ms. Presley, students, you had 2 questions, so come on up and ask your other.
I have like 1 question. What was your most favorite experiment that you ever done?
Cool. Dendra, why don't you kick us off with that?
Ooh, okay. My favorite experiment. Ooh, it's tricky.
No question.
I do lots. So actually, it's very true. So a lot of my experiments, I get to look through a microscope. I have samples that I get to look at. So we actually have a collaboration with a hospital, a local hospital here. And my current lab actually looks at something called the placenta. So I don't know if you guys know what that is. It's the organ that helps a baby grow when it's in the mom's belly. So if you guys have ever heard of that, it's called, yeah. So a placenta is really cool, and you only have it when you're pregnant. And we don't know a lot about it. So we actually get samples from moms when they give birth. They sign over for us, and then we get to do experiments on those. And I think that is so cool. So that's definitely my favorite.
Good answer. And back in Laurier, what's your favorite experiment?
Yeah, I think the favorite experiment I had when I visited the University of California, San Diego last fall, there were grad students who are involved in the outreach for the Center for Aerosol Chemistry there. and they have demonstrated for me how to create a cloud in a water bottle.
Cool.
I know it was an amazing experiment because what it was involving is just, you know, this 4-gallon water container, and then you take out air from it through one of those bike
Vacuum pump.
vacuum pumps, or just, you know, the bike gas, what do you call it? I don't know, I'm not a biker, so I don't know the language of that, but anyways. And then you actually just introduce a little bit of aerosols from a burning match just to have some particles inside. Yeah. And then you quickly introduce atmospheric air into the container. So there is a process that happens, gas expansion, and during gas expansion, water condenses on the particles, and you can see a cloud with a laser pointer, because the scattering of the laser pointer will tell you that you have something there. And I thought that was the most fascinating experiment ever. It's called Cloud in a Bottle.
Fantastic. Okay, so we've got dancing spaghetti, we've got clouds and bottles, we've got placental, you know, donation. This is very diverse. I am going to turn it over to Ms. Michael's class. If you guys have a question, wanted to come up, go for it.
We have a couple of questions. This one is for both speakers.
Okay.
Hi, my name's Sachi. How do you think we're gonna fix world problems?
Ooh, no pressure at all. Okay, we'll start with that one for both speakers. Dendra, I'm going to start with you again. Come on up. How are we going to fix world problems?
Okay, well, I think there's a lot of world problems that we can definitely work on. I think the biggest one for scientists we're thinking about is climate change, and how we make sure that we are being responsible with our carbon use. So that's the reason why everyone's a little scared of the word climate change, because people don't really know how to, I guess, change their habits yet. So we do a lot of these things without thinking, just because our parents taught us how to do them. And so, you know, we use our plastic bags and all these things without thinking about the long term. So I think the big thing now is to just learn more about it and try to change our habits a little bit more, you know?
Fantastic. All right. And then Laurier, what do you think for solving world problems? Again, no pressure at all.
Well, I think what the world needs right now is kindness and compassion, and actually the willingness to open our minds and to learn about each other as equals. Because and actually recognize the interconnectedness of this world. What globalization have failed into, despite the fact that we're all connected virtually, is that it did not succeed at igniting this kindness and compassion in all of us. So be kind to each other, get to know each other at a personal level, and be compassionate with each other. Help each other succeed, because we need all hands on deck for solving the world problems. Every one of you was created for a reason and with a special, unique skills. Therefore, your job is to know who you are and what skills you have to offer the world, okay? And you need to learn science, because science will be one of the tools that you need. Because I don't have to brag too much about science, but it will help you develop critical thinking, problem solving. The training of science creates from you a problem solver. So when you see a challenge, you do not run away from that challenge. You actually think about it, well, oh, it's interesting. That challenge presents a set of opportunities for me. And because I know that I am skilled at X, Y, and Z, I'll be able to tackle that challenge. So be confident about your skills, learn mathematics, be good at math, and be compassionate and kind with each other, and talk with each other as equals, not as somebody superior than the other. That's the message I would love to give you.
Fantastic, ladies. Those are great answers. So I'm going to go back to Ms. Michael's class for a second question in a minute. But before I do, on that note of kindness, Ms. Presley's class, when we started this session, can you tell us a little bit about what you guys are doing in your class today and this week?
I told them the kindness because I had the vote. So tell them about our kindness week.
So this week it's 100th day of school.
Today.
So now,
Today. today. So now we are doing Spirit Day and we're wearing bows. Bow ties.
Fantastic, ladies. Well, I just wanted to highlight that. So thank you so much, girls, for sharing that. Miss Michael's class, we're going to come back for a question for you guys, and then we'll go to Miss Curtin's class.
Okay, I have another question here, but I did want to tell you that many of the students here, and that's where this question came from, have just been talking about what action we need to take to help the planet. So that's why we're wondering about that, because we're starting a project. And now a question, here we go. Okay.
What was the yellow thing at the beginning?
I think there was a picture of some students with experiments.
Okay.
And on one of the desks was a kind of a thing, it almost looked like a yellow duck.
Okay.
And they were wondering what it was, if either of you remember.
Yeah.
What was that in my
I think so. Yes,
Yeah.
I think so.
Okay.
So if you want to bring up your screen share again, we can identify the mystery duck. While you're doing that, I want to stress too something that we've been doing. We do a lot of conservation sessions, and so one of the big things that we've heard from a lot of our speakers this month is that conservation has to be local. So another way to solve global problems: protect the things around your home, protect your neighborhoods, protect your parks. Those sort of things amplify wildly and have a big impact. All right. Oh, yellow duck. What is that thing?
Is this one here, the one that you're talking about?
I think it's on slide 12. It's
No.
in slide 12.
Slide 12, apparently.
Yeah.
Okay, 1 second.
Keep going.
I like that, whatever that thing was, though. That was a freaky thing.
This is slide 12. This one?
The one where you're showing outreach at Laurier.
You're showing outreach. Keep going.
Yeah.
There we
That
go.
one.
What is that? Yeah, what is that?
Yeah, so this was actually foam. We ended up having a reaction with a few ingredients that you can see. There is a dish soap in here, and I think we had some like vinegar and maybe carbonate, but we ended up creating this foam with soap in the graduated cylinder when we started the reaction. So the whole thing just blew out as a duck, but it's not a duck, no.
Fantastic. Well, now we know again. So we've already asked today, what sort of things you can do with chemistry, and that is the answer. You can make creepy foam weird ducks that no one can identify. Okay. All right. On that very scientific note, and great question, guys, I want to go to Michelle's class back in Alaska. If you guys want to end us off with a question, because we are
perfect. We're going to follow suit with the 2-question thing. So I think they'll be.
Do it.
Go ahead.
How many like
experiments?
Yeah, how many experiments can you do in a day?
I'm going to ask both of you actually that. How many experiments can you do in a day?
Well, how many would you like to do in a day? Because honestly, it's not about the number. It's about the length of the experiment.
A long type, some of them are short.
Yeah, some of them are long, some of them are short. Exactly. So it depends. And it depends on your level of skill and training. When you become trained and quick, then you can fit in more than 1 experiment per day. How about you, Dendra? What do you do?
Yes, I wholeheartedly agree. I think it totally depends on how often you do these experiments. But for me, probably my record might be somewhere between 6 and 8, depending on the length of them. There's definitely, all of them usually take at least 3 hours. So they take a lot of time. And so depending on if you have breaks, you can just start multitasking and doing something else. And so.
Fantastic. By the way, I love that you guys brought up that it takes, a lot of skill. So this is something that a lot of people don't think about with science. It's like sometimes manual dexterity. The last experiment I had to do when I was in school was take organs out of a fruit fly. And I can tell you, I accomplished no experiments in a whole day that day. Let's go back to Alaska for one more question, and we'll wrap it up with that.
Go ahead.
I heard that in the news that we're going to be in a mini ice age. Is that going to affect the climate change thing?
Either of you have thought of that? I know it's not your specialty, ladies, but if either of you have a comment on mini ice ages and climate change.
And burning garbage, how the burning garbage thing is possible without chemicals.
Yeah.
Burning garbage without chemicals. I would, okay, so let's talk about the mini ice age. What I understand is that the major impacts of climate change will be flooding in some areas and droughts in others. There will be some areas that will experience very intense winter episodes, and others that will experience mild winters. So generalizing impacts of climate change will not actually be a useful way of talking about the issue. But in general, there will be intensification of events that have been naturally occurring over longer periods of time. They will occur over shorter periods of time, and they will be very intense when that happens. Regarding garbage, well, this is where the issue of separating garbage is important, and recycling as much as possible is important. When toxins are released when we burn stuff like plastics or electronics, and that can release toxic fumes. If these fumes were not contained, then we basically endanger exposure to harmful chemicals. So it's very important that we separate the waste. We try to recycle as much as we possible. The food can be used for fuel or composting to soil and return it to soil again. The plastics, I mean, we need to try to minimize our dependency on plastics, like we are trying to minimize our dependency on fossil fuels. So that will be the best approach, is to actually treat the problem at the source instead of at the end of the pipe. So if we know, we have to be conscious of our activity to estimate, to predict how much waste will be generated from a given activity before we start, in order for us to take all the precautionary steps to minimize the waste or to generate waste that could be recycled to begin with. That will be the best approach.
Fantastic. Dendra, did you have anything to add to that, or?
I completely agree. I have my own composter at home. Our city doesn't have a green program built in yet. And so we went out and bought our own. I think there's so many small ways that you and your families can start changing those habits and start getting those things so that we're helping the environment for sure.
Amazing. And I want to stress too, as you had mentioned a few times, will be occurring. Climate change, I mean, we're seeing this now. When I was a kid, it was something that was in the future that was going to be happening. Now we're seeing Australia on fire, BC on fire, California on fire, droughts around the world. Like, these issues are happening now, and it can be distressing and a little disheartening. But by the same token, it's kids that are your age and just a little bit older that are leading the charge. I think everyone assumed that it would be Dendra and I's generation that would be, leading the charge on climate change. And instead, it's you guys. Look at kids around the world, tens of millions of children marching and making real difference and becoming Time Person of the Year and Nobel Peace Prize nominees because they're fighting to save the planet and do these fantastic things. So that's what this campaign is all about, that Farah's been talking about. That's what highlighting incredible women in science is all about, is to inspire you guys to do a lot of these things yourselves and make spaghetti dance and make weird foam ducks at the same time. Like, it's a two-way street. So with that, I want to wrap up by just asking the two of you, I'm starting with Dendra, how can we inspire girls to do, like, kids of all genders, but girls especially with this International Day of Women in STEM, how do we inspire girls to do more and get excited about STEM and, change the world?
Sure. I think the biggest thing is for you guys to get curious. Get curious about the world, about what makes things work, what makes things tick. Ask questions. Go to a library and read some books and really try to understand everything around you. And that's boys and girls alike. I think we need everyone on board to understand more about our world and to kind of become the future scientists that we need. So.
And then Laurier?
Yeah, I agree wholeheartedly. Curiosity is the number one ingredient for you to achieve and to persevere in science, and also read memoirs. I find a lot of inspiration in memoirs and short stories. Talk to your teachers about your interests and develop and talk to seniors. Seniors have a lot of wisdom to offer the young generations, and I hope that, and I do not think that it's the intellect, it's what in here that matters, and therefore you have to be confident of your skills and make sure that you you educate yourself and you study well and you take school seriously and therefore you build the toolkit that will be at your service when you want to utilize whatever of it that you need. So.
Amazing. Speaking of memoirs too, I'm going to share these in a link when we're done this session about 2 really fantastic books for our classes. Women in Science, 50 Fearless Pioneers Who Changed the World by Rachel Ignatowski. Really amazing illustrations, really inspiring stories. And then Brazen, Rebel Ladies Who Rocked the World, which is a bit of science, but a bit of a whole bunch of other fields as well. And we're going to share those resources when we're done, so do check those out. Farah, before we wrap up, is there anything you'd like to share, one last bit on the campaign that you guys are running?
Wanted to say thank you everyone for tuning in today. If you do want to consider getting a poster or calendar, feel free to check out the links that I've dropped in. And there are so many women in science role models out there. I would encourage you to just read up on one and see, like, if they can be it, you can be it too. And I look forward to calling you all scientists one day. Thank you.
Outstanding. Well, ladies, I know it's all new for all our speakers, and this is the first session for all 3 of you. But what we do at the end of every session is I'm going to demute the microphones of all 3 of our classes joining us. And so, boys and girls, if you guys could get ready to join me in saying a huge thank you to our speakers. Ms. Carton, Ms. Presley, and Ms. Michael's class, you guys are all demuted. Go for it. Thank you so much. Awesome. Thank you so much, and we look forward to having you back soon. Thank you, Dr. Al-Abadleh. Thank you, Ms. Hillier, and thank you guys, and we really appreciate you guys being here today. Bye for now, everyone.